So this is a lecture for the 7-1 material, and the Wiley Plus assignment is already up. This information, now we're switching from fractions to decimals in Chapter 7, and so we've got some terminology that we've got to look at. First is we know the idea of place value from previous classes, but we're going to take our place value from thousands to hundreds to tens to ones that we dealt with in bases, and now we're going to go beyond that to tenths, hundredths, and thousandths. So the THS on the end is what's going to indicate that we're in the decimal place values, or the place values that are less than 1. So you want to be comfortable with these words, how to spell them, how to use them. In terms of the number line, we've talked about where the fractions are on the number line, and now we're going to talk about if you break the number line between 0 and 1 into 10 spaces, then you'll be dealing with tenths. So this line right here would represent 1/10, 2/10, 3/10, 4/10, 5/10, 6/10, 7/10, 8/10, 9/10, 10/10, and 10/10 will also be the number 1. And if you decided to break each of these areas into tens, then you would be talking about the hundredths place. But on a number line, that's a little hard to see. So if we're dealing with hundredths, we are going to use a hundredth chart. And so if I color these 3 spaces on my hundredths chart, then that would represent the number 0.03. So 3 hundredths is 0.03. So if I then said, oh, no, wait, I'm going to color all 10 of these, then my number would change from 0.03. I'd have 10 hundredths, and that would be represented as 0.1. You could think about it as 0.10, 10 hundredths, but any zero that comes after a decimal place and after the last significant digit, and the significant digit is a digit other than 0, that 0 is not necessary, because it's not giving any more information than 0.1 would. 1/10 is the same thing as 10 hundredths. When we're naming decimals, we have the numbers that are occurring before the decimal. We've talked about how to name them. 345, not using the word and, but the decimal is where that word and comes into play. So this number is 345 and 678 thousandths. And so you're going to name this number just like you would if it weren't after the decimal, but then you're going to put the correct place value at the end. So because this is the 10th, hundredths, thousandths, that we're going to call that thousandths. So you want to be comfortable with writing the name of the number, or taking the name and writing the numeral as well. So we've still got that issue of a name and a numeral for every number that you're responsible for. Expanded form, we've talked about it in bases, but now we're going to talk about it when we get into the decimal version. So this number that we talked about up here could be written as 3 times 100 plus 4 times 10 plus 5 times 1 plus 6 times a tenth plus 7 times a hundredth plus 8 times 1,000th. And so that's one way to write expanded form for your decimal. The other way is to use exponential. So instead of 100, you call it 10 squared. Instead of 10, 10 to the first. Instead of the number 1, 10 to the 0. 10 to the negative 1 is how you write a tenth. 10 to the negative 2 is a hundredth, and 10 to the negative 3 is a thousandth. So remember that whenever you have a decimal, or have a negative exponent, the negative part is the part that flips 10 over. So it flips this base of 10 over and makes it a tenth. And the integer part, the positive integer part, tells you how many times you use 10 as a factor. So 10 to the negative 4 is the same as 1/10 to the 4th power, which is a tenth times a tenth times a tenth times a tenth. And that's why it's 1/10,000. So when you see a negative exponent, you want to remember it doesn't make the number negative. It makes the number, the base that it's associated with, flip over and become the inverse of what it was. So that's how a negative exponent works, and that's why we use negative exponents once we get down to the decimal part of our number. Okay, moving on to the second page, you want to be comfortable with how to turn a fraction into a decimal. And so we've got a process for that, turning a fraction into a decimal. You want to, a couple different ways to do it. You know, if you have a calculator, really what you're going to do is take the numerator and divide by the denominator. So let's do a simpler problem here first. If you had a calculator and you took 3 divided by 5, you're dividing the number 5 into the number 3. And because 3 is smaller than 5, you need to add a decimal and a 0 and divide 5 into a number. If you ignored the decimal, 5 into a number that would be larger. So it's like dividing 5 into 30. But the decimal that you added to be able to divide the 5 in needs to go up here as a part of your dividend. And when you divide 5 into 30 and get 6, then you can say 5 divided into 3 is 0.6. So that's one way to think about turning a fraction into a decimal. The other way to think about it is if you can get the denominator to be a multiple of 10, then you will be able to change your fraction into a decimal, because the denominator that's a multiple of 10 will tell you what place value you're in. So if you rewrite 3/5 by multiplying denominator by 2 and numerator by 2, and you get 6/10, then you know you can write your decimal as 0.6, because that's the same thing, 6/10. So one way or the other, you either divide or you rewrite your fraction with a multiple of 10 in the denominator. However, when you end up with a fraction that has exponential in the bottom, what you're trying to do is use this method. Because what you will do is take the 2 that's to the 4th power and multiply on a 5 to the same power, because 2 times 5 is 10, and that will give you 10 to the 4th power. When you multiply exponentials like this, if the exponents are the same, you can multiply the bases. And so you're taking that factor that's going to create a multiple of 10 in your denominator, and you multiply it by the denominator and the numerator. And that way you're creating your place value of 10,000. And you can say the answer is 0.1875, because tenths, hundredths, thousands, 10,000ths, that's matching this denominator. So you can check yourself on your calculator by doing the division, but if I ask you to do this, turn a fraction into a decimal, and it's written in this way, what I'm asking is I want to make sure that you know you need a multiple of 10 in the denominator of your fraction to turn it into a decimal. So you want to be comfortable with both ways of doing that, not just the division way. because the division way doesn't necessarily explain quite as well as this, how a fraction and a decimal are related. So to me, it's very important that you can get to that point where you can realize that a multiple of 10 in the denominator will make this problem much easier. Here's a theorem that you're responsible for. If you have any fraction in simplest form, so that means it's been reduced, any greatest common factors have been divided out, then the fraction has a terminating decimal. Terminating means it's going to eventually stop. A terminating decimal representation if and only if B contains only 2's and 5's in its prime factored form. So if you take the denominator and you do a prime factorization on it, and all you get at the end is 2's and 5's, then your decimal will terminate. So let's look at an example of a decimal that doesn't terminate. Okay, a simple one that doesn't terminate. The number 1/3. It's 0.3 and it keeps on repeating. Well, it doesn't have 2's and 5's in its prime factored form. It's got a factor of 3. So anytime there's a factor of 3 in the denominator of your fraction, it will not terminate. But if you look at 1/4, that's 0.25 and it stops. Well, 1/4, if you look at 4, it only has 2 and 2 in the denominator. If you, hold on one second. Can I call you back in a sec? I'm just videotaping. Okay. So the 1/4 is going to terminate, 1/3 is not going to terminate. 1/8 is 0.125. 8 is 2 to the third. It only has a factor of 2 in the denominator. So that's a quick way that you can tell whether a fraction is going to terminate. Just look at the denominator in prime factor form. Problems. When you look at these problems, again, it's not, I know you can do them on your calculator. That's not the point. The point is looking to see if there's a faster way to do the problems using commutative and associative. So what you want to notice in number 1 is how the tenths in these two numbers would add to 10. 7/10 and 3/10 is 10/10. So adding these two numbers first, so using commutative to change the order, using associative to change the parentheses would be a smarter way to go. And these add to the number 6. And then you'd add on 3.2 and you can get 9.2. Remember, when we're adding things that are in the same location in terms of place value. So 1 and 4 was 5, and this extra 10/10 made it 6. Then I add the 6 and the 3 to get 9.2. Same here. I can take 0.5 times 6.7, but if I do it the other way and take 0.5 times 4, this problem's going to be a lot simpler because 0.5 is a half, and a half of 4 is 2. The other way to think about it is to actually multiply, and remember the rule for multiplying decimals. If there's one digit after the decimal here, there'll be one digit after the decimal here. So the answer to 4 times 0.5 is 2, either way you think about it. And then you're taking 6.7 times 2, which could be 6.7 plus 6.7, or you could actually do the multiplication. And when you do the multiplication, here you get 14, carry the 1, you get 13. One digit after the decimal, so one digit after the decimal, 13.4. You get the same thing if you decide to add 6.7 to 6.7. Taking 6 times 8.5, there's another way you can think about it, and it has to do with the distributive property. You can think about 8.5 as 8 and 5/10. 8 plus 5/10. And then if you distribute here, you'll get 48. And distribute here, a half of 6 is 3. And you can get the answer to that problem without having to actually multiply and then figure out where your decimal goes. So anytime you take an integer times a decimal, and the decimal has digits before and after, you can distribute through and do the integer multiplication and do the decimal multiplication and then combine them with addition. So it's another way to think about these problems, and you want to be thinking about the best way to do these things, not just the way that you're familiar with doing them. This would be the opposite. So these two kind of problems are opposite of each other. In here, this is already written out in distributive form. So you could imagine that the problem said this before you distributed. 0.25 times 17, the commutative property says this is what I just said, it's just in a different order, and 0.25 times 23. So rather than taking a fourth of 17, which is what 0.25 is, and a fourth of 23 and then adding them together, you could just take a fourth of these added together, which is 40. Oops, sorry, a fourth of 40 and get 10 in your head without doing any difficult kind of multiplication or division. If you don't realize that 0.25 is a fourth, that's not a big deal. You could do the multiplication, but it's still going to be easier to multiply 0.25 times 40 than 0.25 times 17 and 0.25 times 23 and then add them. And when you multiply here, and you get 1,000, you just have to remember there were two digits after the decimal here, so you want your decimal right here, 2 digits after it, and that's 10. So either way. When you look at this number 5, you want to realize that this is written in scientific notation. Scientific notation means this number is between 1 and 10, and then you put your exponent here to say how many times you want me to move this decimal to the right if it's a positive number. So I'm going to take 2.76 and move the decimal 1 2 spaces over and get 276. The same with 7.54. I want to move it 4 digits to the right. So when I go 1, 2, 3, 4, I've got to fill these spaces in with zeros because I've just moved the decimal over here. Zeros to the left of the decimal at the end mean something. Zeros after the decimal, they don't mean anything, but before the decimal, they do. So I want to call this 75,400. And the final thing you need to know how to do is round. So rounding to the nearest tenth means that your answers should end at the 10th place value. And so that's this place value, 0.5. So you look to the right, and if this number is 5 or greater, then you're going to round this up. So to the nearest tenth, this is going to round to 6.6. And to the nearest hundredth, I'm going to look at this place value. To the right is 7, so that's also going to round up, 6.57. Okay, so a little quick review of decimals and things that you should know and little tricks that you can use to do your Wiley Plus homework assignment, which will be due after break. And the quiz is still on Friday for 6-1 to 6-3. So that homework assignment was a worksheet you're going to bring on Friday. There's also an optional Wiley Plus on 6-1 to 6-3 if you want to do it to get ready for the quiz.